Hey, it's me. And I'm going to walk you through today the typical college lab, and for that matter, high school biology lab in enzymes. So I'm starting out with a look at milk here and an enzyme that you can buy in the store. So let's review just a little bit here. Enzymes are a type of protein, and in that family of proteins, the enzymes are famous for lowering their activation energy, making reactions happen quicker, and oftentimes without a particular enzyme, a reaction does not occur at all. Most of them end in ASE and they have a job. So there's usually a substrate that they work on. And for instance, it might be breaking apart sugar in this case. So some people are lactose intolerant. They can't drink dairy or eat ice cream and that kind of stuff because they don't have the enzyme that'll grab onto that disaccharide and break it into two monosaccharides. And that's really what makes a disaccharide, palatable. So, and a consequence of not having that enzyme is if you do ingest those dairy products, it's usually a very unpleasant gastrointestinal event. So no fun at all. But there's a cure. And the cure out there is because we have lactase, which is a naturally occurring enzyme in many people. But if you are lactose, which is a sugar, lactose intolerant, you can take this enzyme essentially before you enjoy dairy products, and it'll break apart that lactose sugar for you. So there's a lot of experiments we can do, or you can do an entire lab on taking milk, which has lactose sugar, and you can test it for simple sugar to see if this disaccharide got broken or not. So you could test milk for the disaccharides and the monosaccharides and you'd see that there's mostly lactose, a disaccharide in the milk, and we have a test for glucose. And so after using lactase, if we add milk to lactase, we would expect the enzyme to do the work and break apart that disaccharide and make it a monosaccharide. So that's kind of a typical look at an enzyme. So we have at this high school, we've built an entire lab around those two things. Can you be mean to the enzyme? Can you cook it? Can you insult it with pH? What makes an enzyme tick? So anyway, this last 2-day time period we have before the end of the semester, I thought I'd ask you guys to do the enzyme lab, the classic enzyme lab, which is not about lactase at all. It's more about catalase. So here's what your lab looks like. Not that this is important because you already have access to this. Here's the subject matter. This is chicken liver. I just bought it from Kowalski's across the street. You can get a tub of chicken liver for about $1. Anyway, so one of the classic things we do is there are enzymes called catalase in this chicken liver, and it was flash frozen, so it doesn't know it's dead. The enzyme still works. The catalase enzyme, which specializes in breaking down peroxide, which is H2O2. This is in the introduction of your lab. All you gotta do is hit that enzyme with peroxide, and its job in life is if it ever sees peroxide, it's supposed to break it into oxygen bubbles and water. So let's demonstrate that. We have over here, oh, by the way, this is a prop too I set aside. Do you suppose it would matter when it comes to enzymes if I were to add some peroxide just to this big fat chunk of chicken enzyme? You'd expect this bubbling reaction as the oxygen is released. But how that reaction differ if I took a mortar and pestle, took the chicken liver, threw it in here, ground it up with some sand as an abrasive, what would we call it? Emulsifier or an abrasive substrate that we could break it up. And so we'd increase the surface area. And what do you suppose would happen? You can guess your way through that. With more surface area, more enzymes are available. And so you'd expect a more vigorous reaction as opposed to a big chunk. So to deal with that, what I did is I threw some chicken liver in a food processor with a little bit of water and made a slurry. So this is liver slurry. So let me kind of show you what this might look like. Here's your typical lab. I've got 10 mils of peroxide. I'm just going to throw that Let's see if I can make you watch this while I'm doing it here. Yeah. So we're going to take the 10 mils of peroxide and we're going to put that in here. So this is the poison, if you will. And I'm going to add, so here's the 10 mils of peroxide in there. Gosh, that kind of looks like a lot. I think that is going to be, that's going to create a huge mess. But I'm going to take 5 mils, which is a lot of catalase. And that's my slurry. And I'm going to set this in here so when if it goes crazy, you can see it happen right here, live. Live. So here goes the catalase enzyme. Oh my gosh! Oh. So that's a huge fat hairy reaction. And there's enzymes in there, and what they did is every single molecule of H2O2 they saw, they turned it into oxygen and water. So I could drink this actually, and all it'd be is liver and water, and the oxygen, of course, wouldn't bother me. So I'm not gonna. I'm not crazy. Anyway, so that's a reaction, your basic reaction. Now, if I were to, well, here's the question. Do you think if I had a quarter or a tenth as much slurry or liver enzyme availability, would the reaction happen again? Well, here's something we can test right in front of you. I can take some more peroxide, and if is the enzyme done, or will the enzyme just keep working on more peroxide? Well, let me throw some more, if I throw some more enzyme in there, maybe it's not completed. So I'm going to draft up another 5 mil. That's a lot of enzyme. I'm going to throw some more enzyme in there. If there's still catalase, there's going to be a big reaction. There's still quite a bit of reaction. So there must have been some left over. What if I really want a reaction, if I add more peroxide, that's also going to be a problem. So I'm going to add more peroxide here. It's going to take a while to get down there. Yeah, look at it go crazy. So enzymes, the whole point of that is that the enzymes, you can see it fuzzing over. Enzymes are never done. So in your cells, you've got all these different enzymes that each have one job. And in this case, we have catalase. In your liver cells, you have them as well as chickens, as well as beef. You could do this with beef liver as well. But those enzymes, this particular enzyme does one job. Whenever it sees peroxide, it breaks apart. And if I wanted to wreck this whole jar of peroxide, if I took one small piece of that slurry and dropped it in there, it would turn the whole bottle into oxygen and water. It would just keep working. It shouldn't have been so frothy when I added more peroxide, more enzyme, because the enzyme is going to work until it's all done. But I think I didn't let it do its full job. Anyway, so what's going on? We have catalase the enzyme taking H2O2, hydrogen peroxide, and making it into oxygen and water. All right, so if you wanted to quantify this is kind of neat. What if I set up my liver peroxide in here, in this setup, and then I took this tube and I took this graduated cylinder and I filled this full of water. I turned it upside down so this graduated cylinder is filled with water. What if I snuck this tube into the water and into the mouth of that graduated cylinder, and then I reacted? Couldn't I quantify how much gas was produced from those two liquids? Because the peroxide's a liquid and my slurry is a liquid. And I could just see the oxygen bubbles captured here. So I probably could quantify this if someone asked you to design a lab where you would quantify, the gas amount. Well, this would be a way to do it. It's really not all that sophisticated, but it would work. All right, another question asked oftentimes about enzymes is pH. And so I set up another little experiment. Let me grab my peroxide and I'm going to go grab another 5 mils of liver slurry. Ugh. Whoa. Okay, so let's try this. What if So I put some, actually I already added my slurry. I guess I don't need my slurry because I added some slurry to lemon juice, which has a pH of about 2. And so I'm wondering if that wrecked it. So I'm gonna add this lemon juice slurry. It's got little particles of enzymes floating around there. I'm gonna add this lemon juice. So in other words, the real question I'm asking here is, will pH wreck our enzyme? And I'm going to use the other one as kind of a control here. I'm going to put regular slurry on this side. And then I'm going to put peroxide into both of them. See what happens. Oh. No. Don't try this at home. We are professionals. Oh, you know what I should do? Ah. Okay, these will pour easier, and I can quantify how much peroxide. I'll put another 10 mils there, another 10 mils here. So, what do you think is going to happen? We're going to add fresh peroxide to 2 test tubes, each that have liver slurry, but one of the solutions of liver slurry was bathed in acid. So will that wreck things? So I'm going to add some here. I don't think it'll necessarily be a big change. It has, in saltive pHs, here's the lemon juice. Wow, look at that. It worked. It wrecked the enzymes. I didn't think it would. I want to put some, just as our control, this is regular. Oh my God. Huh. So the way we probably describe